In the vast expanse of the cosmos, where galaxies cluster in shimmering webs of light, there exists a region so empty, so profoundly desolate, that it defies our understanding of the universe itself. This is the Boötes Void, a spherical chasm spanning 330 million light-years, a space so vast it could swallow 1,000 Milky Way galaxies with room to spare. Unlike the darkness between stars or the gaps between galaxies, the Boötes Void is not merely empty space. It is a place where galaxies simply do not exist, where the cosmic web has unraveled into nothingness. Its discovery shattered long-held assumptions about the structure of the universe, forcing astronomers to reconsider how matter is distributed across the cosmos. If you were to shrink the Milky Way down to the size of a quarter and toss it into this void, you'd need 999 more quarters just to begin filling the emptiness. Light, traveling at 670 million miles per hour, would take 330 million years to cross from one side to the other. To put this into perspective, imagine finding a parking lot in the middle of Manhattan, except this parking lot is bigger than Manhattan, bigger than New York State, bigger than the entire continental United States. This is not just a gap in the universe. It is a cosmic anomaly, a gravitational desert, a void so vast it challenges everything we know about reality. In 1977, astronomer Robert Kirshner and his team pointed their telescope toward the constellation Boötes, expecting to see the usual scattering of distant galaxies. Instead, they found nothing. No faint glow of galaxies, no clusters of stars, not even the dim haze of cosmic dust. Just emptiness, stretching so far that light itself seemed to vanish into the abyss. Kirshner had stumbled upon something that should not exist. At the time, astronomers believed the universe was relatively uniform, with matter distributed evenly across space. Galaxies were thought to form a vast cosmic web, interconnected by filaments of dark matter and glowing clusters. But the Boötes Void broke all the rules. The void wasn't just a little sparse. It was nearly devoid of galaxies entirely. Expected galaxies in a region this size? Around 2,000. Galaxies actually found? 8. That's right, 8 lonely galaxies floating in a space that should have held 2,000. Imagine walking into a concert hall built for 2,000 people and finding only 8 scattered individuals sitting in the darkness. The silence would be deafening. The emptiness would feel wrong on a fundamental level. These 8 galaxies, now known as void galaxies, were unlike anything seen before. In the normal universe, galaxies live in neighborhoods. They cluster together, gravitationally bound in groups and superclusters. They collide, merge, and interact over billions of years. But the void galaxies were different. They were cosmic hermits, isolated beyond anything astronomers had ever seen. Nearest neighbor to any void galaxy, around 50 million light-years away. For comparison, the Milky Way's nearest neighbor, Andromeda, is only 2.5 million light-years away. This extreme isolation had profound effects on their evolution. Smaller and dimmer than galaxies in denser regions, fewer heavy elements, suggesting slower star formation. Sleepy star production, as if the void itself had stunted their growth. Scientists call this phenomenon galactic underdensity, but that sterile term doesn't capture the true strangeness of these galaxies. They are not just separated by distance, they are shaped by an emptiness so profound it alters their very nature. The probability of such a massive underdensity forming by random chance? Less than 1 in a million. The Big Bang should have left behind tiny density fluctuations, but those fluctuations should have averaged out over such vast scales. Finding a void this large is like flipping a coin and getting heads 1,000,000 times in a row. Yet, here it is, a 330 million light-year hole in the universe, staring back at us with silent defiance. Even more bizarre, the 8 galaxies inside the Boötes Void aren't scattered randomly. They are arranged in a perfect tube, like subway stations along an invisible cosmic highway. Each galaxy is spaced roughly 40 million light-years apart. They move in synchronized motion, as if guided by an unseen force. This filament structure suggests that the void is not just empty, it has hidden architecture, perhaps shaped by dark matter currents or remnants from the early universe. The void is not just an absence. It is a cosmic anomaly, a gravitational enigma, a silent challenge to our understanding of reality. Now, the void is not a static emptiness. It is expanding, growing larger and emptier with each passing million years. But here's the terrifying part. It's expanding faster than the universe itself. While the rest of the cosmos stretches due to dark energy, the Boötes Void seems to be actively pushing matter away, as if some unseen force is clearing space with unnatural efficiency. Imagine a balloon with a small hole that grows larger as you inflate it. The hole doesn't just stay the same size, it consumes more of the balloon's surface with each breath. The Boötes Void behaves the same way, but instead of rubber, it is devouring the space where galaxies should exist. Measurements show that the Boötes Void is expanding at a rate roughly 10% faster than the cosmic average. Normal cosmic expansion, due to dark energy, 67 kilometers per second per megaparsec. Boötes Void's expansion, 74 kilometers per second per megaparsec. This might seem like a small difference, but over billions of years, it means the void is actively repelling matter, creating a runaway effect where emptiness breeds more emptiness. In normal regions of space, gravity pulls matter together, forming galaxies and clusters. But in the Boötes Void, the rules reverse. Underdensity forms. A region becomes slightly emptier than its surroundings. Gravity works in reverse. Instead of pulling matter in, the void's lack of mass creates a gravitational hill. Matter flows outward. Like water rolling downhill, galaxies and gas are pushed away from the void. Feedback loop begins. The more matter leaves, the stronger the effect becomes. This creates a cosmic vacuum cleaner, where the void sucks matter out of itself, growing ever larger. If current expansion rates continue, within 5 billion years, the Boötes Void will double in size. The 8 surviving galaxies inside will be pushed further apart. their isolation becoming even more extreme. By the time the Sun dies, about 5 billion years from now, this region of space will be twice as empty as it is today. But the implications are even more unsettling. This accelerated expansion suggests that dark energy behaves differently inside the void. Dark energy, the mysterious force accelerating the universe's expansion, may be more concentrated in the Boötes Void. Some theories propose quintessence, a dynamic form of dark energy that becomes stronger in low-density regions. False vacuum decay. The void could be a bubble where the laws of physics are different, expanding exponentially. Cosmic fossil, a remnant of the early universe where inflation never properly ended. If true, the Boötes Void might be a glimpse of the far future when dark energy dominates and the entire universe becomes a vast, empty void. Around the edges of the Boötes Void, galaxies huddle together in dense clusters, as if fleeing the growing abyss. Galaxy density at void edges, 3 times higher than normal space. Structure. These galaxies form void walls, massive curtains of matter separating the void from the rest of the universe. It's like a crowd of people pressed against the walls of a room, all trying to stay as far as possible from something terrifying in the center. The transition from normal space to the void is shockingly abrupt. Normal space. Galaxies clustered in a cosmic web. 20 million light-years later, almost nothing. This cliff-like drop in galaxy density defies our understanding of cosmic structure. Normally, density changes should be gradual, shaped by gravity's gentle pull. But the Boötes Void looks like it was carved out by force. Dark matter is the invisible skeleton of the universe, an unseen force that binds galaxies together in a vast cosmic web. But in the Boötes Void, even dark matter seems to be missing. The expected dark matter density is around 27% of the universe's mass energy. Measured in the Boötes Void is less than 10%. This is a profound violation of cosmological models. Without dark matter, galaxies shouldn't form at all. Yet the Boötes Void's 8 lonely galaxies exist in defiance of this rule. In the standard model of cosmology, dark matter clumps together first, creating gravitational wells. Normal matter falls into these wells, forming galaxies. But in the Boötes Void, yes, galaxies exist, but dark matter is almost absent. This is like finding a skyscraper built without a foundation. The extreme emptiness of the Boötes Void may not be a random cosmic accident. Instead, it could be a relic of the universe's earliest moments, a frozen quantum fluctuation stretched to unimaginable scales during the inflationary epoch. In the first fraction of a second after the Big Bang, the universe underwent exponential expansion known as cosmic inflation. During this period, tiny quantum fluctuations in the fabric of space-time were magnified to cosmic proportions. Most of these fluctuations became the seeds for galaxies and galaxy clusters. But what if some regions experienced a different fate? The Boötes Void might represent an area where these primordial density variations were not just small deviations, but profound deficits. Instead of creating an overdensity that collapsed into galaxies, this region may have been stretched into an underdensity, an expanding bubble of near-nothingness that persisted for billions of years. Support for this idea comes from the cosmic microwave background, CMB, the afterglow of the Big Bang. In the direction of the Boötes Void, astronomers have detected a significant cold spot, an area of slightly lower temperature than the surrounding CMB. This temperature dip aligns with the void's location and suggests that the region was already underdense when the universe was only 380,000 years old. The cold spot arises from the Sachs-Wolf effect, where photons lose energy as they climb out of a gravitational well that has become shallower over time. In other words, the void's emptiness has been growing since the dawn of the cosmos. Some theoretical physicists propose an even more radical explanation. The Boötes Void could be a boundary between our universe and another. During inflation, different regions of space-time may have undergone phase transitions at different rates, creating bubble universes with varying physical properties. If our observable universe collided with another bubble in the distant past, the intersection could have left behind a vast, empty region, a scar where the two universes failed to merge seamlessly. While speculative, this idea suggests that the void might be a window into a multiverse, offering clues about physics beyond our own cosmic horizon. Another possibility is that the void preserves quantum entanglement from the universe's earliest moments. During inflation, particles that were once quantum mechanically linked could have been separated by vast distances. If the Boötes Void marks one end of such an entangled pair, its properties might be influenced by a distant, unseen counterpart. This could explain why the void's expansion rate differs from the rest of the universe. Its behavior might be tied to a remote region of space via quantum correlations we cannot directly observe. The Boötes Void challenges not just our understanding of galaxy formation, but the very foundations of cosmology. If its origins lie in quantum fluctuations or multiverse dynamics, studying it could revolutionize our knowledge of the Big Bang, inflation, and the nature of reality itself. The void offers a disturbing glimpse into the distant future of our universe. Current cosmological models predict that dark energy will continue accelerating the expansion of space, eventually isolating every galaxy in its own pocket of darkness. The void demonstrates this process already underway on a colossal scale, a preview of the cosmos' ultimate destiny. Over the next trillion years, the expansion of space will stretch the distances between galaxies beyond visibility. The night sky, currently filled with distant points of light, will grow darker as galaxies outside our local group redshift into oblivion. Eventually, even neighboring galaxies will be pulled away by the relentless expansion, leaving our Milky Way alone in an ever-cooling void. The galaxies trapped within the void show signs of premature aging. Their star formation has nearly ceased, their stellar populations dominated by old red stars. These cosmic retirees demonstrate what happens when galaxies are cut off from fresh gas and new interactions. Astronomers studying these isolated systems have found exceptionally low rates of new star formation, a surprising abundance of rogue stars drifting between galaxies, and few globular clusters, suggesting limited merger activity. These characteristics suggest that void galaxies evolve along fundamentally different pathways than their counterparts in denser regions. The void demonstrates that the cosmos is not just expanding, but becoming fundamentally disconnected. As dark energy continues its work, the universe will fracture into isolated pockets of matter separated by unimaginable gulfs of nothingness. This future, cold, dark, and silent, stands in stark contrast to the vibrant cosmic web we observe today. The void serves as both warning and wonder, a reminder that we live in a privileged era when the universe's structure remains visible and its history still decipherable. The Boötes Void challenges us to reconsider our place in the cosmos. Its emptiness speaks to profound questions about the nature of reality, the origins of structure, and the ultimate fate of all things. As we continue to study this extraordinary region, we may find answers to some of cosmology's deepest mysteries, or perhaps uncover even greater questions hidden within the void's infinite darkness.